This is Shakil Ahmed. In this tutorial, we will discuss about correlation analysis. Correlation analysis basically measures the association, linear relationship between two quantities when we have two variables on quantitative scale. We assess the strength of relationship between those two variables. So when variables, we have two types of correlation. The one is called the parametric one that is used when we have data on uh, follow the normal distribution, and the scale of measurement is based on interval scale. Then some correlation. We have skewed data, or when we have ordinal data, we just use the Spearman array correlation. And parametric one. So in this video, I will show you how we can find the scatter plot that makes the association and basically tells the display the strength of association, how the two variables are uh, correlated uh, of a graphic display. So here we have a data set on heart disease, patient with heart disease, and then we can just assess whether the cholesterol level is related to body mass index of the 100 patients. I have just stuck with the data for first 100 patients. So you can just adding a command option, or you can just include the things using the formula. So we have the formula for the correlation coefficient that is called Pearson correlation coefficient. And basically the product movements, basically product of two movements, that is the deviation. In denominator we have the standard deviation of the two variables, and in numerator we have the that is called the covariance. So we will start with finding the covariance, and then we can find the uh, we can find the covariance and find the standard deviation of x, standard deviation of y, and how we can find the covariance. Just use the covariance. We are finding covariance for sample. Just use the covariance sample and select the. You can check the array 1 and array 2. You need to select two arrays. So we are selecting the cholesterol level as array 1, and the BMI. Okay, it's not working. We check. We can just note down the variables columns and then use the uh, cell differences. For example, we have the dth column and ith column. So we can just write D2 and D101 and I2 and I1. Covariance, and you can find the standard deviation. using standard deviation command. Uh, and then again, we need to select the X, for example, that is cholesterol, D2 and D101, and then the standard deviation of Y, that is DMI. So I just find standard deviation, sample, and then I2 and I101. So these are the covariance standard deviation of X and standard deviation of Y. And now we can find the correlation, and that is just the ratio of the covariance and the product of the two standard deviations. We can just use the covariance divide by standard deviation of X and standard deviation of Y. Relation between the cholesterol level and BMI, which is very low, as we have different ranges when it ranges from less than 0.20 or greater minus 0.20, we can say that the correlation is very low. And if it ranges from zero point 0.2 to zero point 0.5, it's slightly high, and then moderate, and then strongly high, and then perfect correlation, that is 1 and minus 1. 1 means there is a perfect correlation, positive correlation between X and Y, and minus 1 means there is a perfect negative correlation between X and Y. 0 means there is no correlation. So the correlation is very low in this case, and we can check whether this coefficient, correlation coefficient, is significant or not. We can use this. Zero. That is our null hypothesis, and we are using the t statistic. And this is equal to R, that is correlation, minus 0. You don't need to write that. And then square root and 1 minus R, 1 minus correlation square, and divide by n minus 2. N is 100. So it's 8. And then we can close the brackets. The bracket here. The square root is for on both numerator and denominator. So we can give it two brackets. Is very low, and we can compare this value with the computed value, the probability value of probability. Distribution inverse, and the probability is 0.95, and the degree of freedom is 9. The tabulated value of test statistics is 1.66, and the calculated value is less than the tabulated value, so we don't have any evidence to reject the null hypothesis and conclude that the correlation between BMI and cholesterol is negligible, almost zero. This is a Pearson correlation we have. Thank you.